Hello and welcome to part 2 of the notes for Unit 4 Lesson 2, Conservation of Momentum. In part 1 we learned about the two types of collisions we study in physics, and I showed you how to do inelastic collision problems. In this part we're going to learn how to do an elastic collision problem and an explosion problem. Explosions, that does sound exciting, doesn't it? Let's start with the elastic collision and look at the formulas for solving a problem with an elastic collision. Remember, an elastic collision is a collision where the two objects bounce off each other with no loss of energy. First of all, the initial momentum formula looks exactly like the formula for the inelastic collision. Pi, initial momentum, equals mass 1, velocity 1 initial, plus mass 2, velocity 2 initial. The final momentum in an elastic collision has two terms as well. Because the objects do not stick together, they stay separate. So the final momentum is m1 v1 final plus m2 v2 final, or mass 1 velocity 1 final plus mass 2 velocity 2 final. Let's see how these formulas work in an example. First of all, we're going to set them equal to each other. We're going to say that if momentum is conserved, which it is in a collision, then the initial momentum, mass 1 velocity 1 initial plus mass 2 velocity 2 initial, equals the final momentum, m1 v1 final plus m2 v2 final. For example, let's say we have a 0.5 kilogram ball traveling at 6.0 meters per second. It collides head-on with a 1.00 kilogram ball moving in the opposite direction at a speed of 12.0 meters per second. The first ball bounces backward at 14 meters per second after the collision. Find the speed of the second ball after the collision. So let's do this example together. You've seen I've made a couple diagrams, one for before, one for after. We can see that before the collision, the smaller ball, which is a mass of 0.5 kilograms, and the larger ball, which is twice the mass, or 1.0 kilograms. The smaller ball has an initial velocity, we'll call that v1 initial, of 6.0 meters per second. And the velocity of the second ball is going in the opposite direction, so it has a negative velocity, negative 12 meters per second. So we'll draw some vectors here showing the initial velocity for both balls, for v1 and v2. The two objects collide, and after the collision on the right side, now the first ball bounces backwards in the opposite direction. We'll call that v1 final, and that is equal to negative 14 meters per second, because the momentum of the first ball was affected by the momentum of the second ball. But what we want to figure out is, what is the velocity going to be of ball 2? If momentum is conserved, we can use the conservation of momentum formula. Initial momentum equals final momentum, or Pi equals Pf. For initial momentum, we'll substitute in our formula from above, m1 v1 initial plus m2 v2 initial equals the final momentum, or mass 1 v1 final plus mass 2 velocity 2 final. So we have several terms here in our formula, but the one we're interested in to find is the velocity of the second object, v2 final. So let's circle that. First thing we need to do here is to get rid of this m1 v1 final term on this side, so we subtract it from both sides. Subtract m1 v1 final, and that will cancel out on the right side. And we're going to rewrite our equation with our values put in. 0.5 kilograms, that's mass 1, times v1 initial, or positive 6 meters per second, plus mass 2 times v2 initial, or 1.0 kilograms times negative 12 meters per second, minus mass 1 v1 final, that's what we just subtracted, 0.5 kilograms times negative 14 meters per second, equals mass 2 times V2 final, or 1 kilogram times V2 final, which is what we're trying to find. So what I'm going to do is I'm going to add all these terms over here on the left side, add those together with my calculator. And if you take the sum of all those terms, you get -2 kilogram meters per second as the momentum on the left side of our formula. So let's write that down. -2 kilogram meters per second equals 1 kilogram, 1.0 kilograms times V2 final. So obviously, you can see if we want to get V2 final by itself, we need to divide by 1 kilogram on both sides. So divided by 1 kilogram, we'll cancel out kilograms on the right side and on the left side. And we're left with a velocity of -2 meters per second for the second ball. So notice the momentum of the second ball is still negative, but it gave some of its momentum to the first ball. Okay, back to our slideshow here for the notes. Let's move on to explosions. And this is everybody's favorite topic, of course, in physics. Nothing more exciting than explosions. Now, not all explosions are the kind of explosions you think of, but explosions also obey the conservation of momentum if no external forces are exerted during the explosion. So if the total momentum before the explosion is 0, the final momentum will also be 0. You can think about if there's a grenade, say, sitting on the floor. If that grenade explodes, all the fragments of that grenade, if you add up all the momentum of those fragments, it will equal the total momentum before, which was 0. So all the momentum would cancel out. Another example of an explosion is, say, rockets in space. The thrust or exhaust of a rocket going one way will propel the rocket in the opposite direction. We talked about astronauts using their jet packs or rocket guns to move themselves around in space. That's just throwing the mass in one way will cause them to move the other way. Let's look at an example of an explosion problem. This may not sound like an explosion problem, but it really is, because these two people are standing next to each other on skates, and they're not moving, so they have no momentum initially. Now one skater pushes off the other one. They push off each other, and the first skater with a mass of 45 kilograms pushes the second skater, who has a mass of 61 kilograms. And the first skater moves away at 4.5 meters per second, so we want to find the velocity of the second skater. So let's again do this example together. Again, I'm going to draw a before and after diagram for this explosion problem. And again, it's an explosion because they're pushing apart and flying away from each other, just like an explosion would. Also, this is called a disintegration problem sometimes. But here we have the before picture. Notice they are both standing facing each other. Neither one is moving. So there is no momentum initially. After the push, skater 1 moves backwards with a velocity of 4.5 meters per second. Skater 2 is going to move in the opposite direction. Remember, for every action, there's an equal and opposite reaction. Newton's third law of motion. So if the first skater is moving away, the second skater will move in the opposite direction. So we have V1 final and V2 final. Now let's use our conservation of momentum formula. We always start with this in these problems. Momentum initial equals momentum final, or PI equals PF. Now the initial momentum is 0 because they're not moving. So we'll put that in for PI, 0 kilogram meters per second. And the final momentum is M1 V1 final plus M2 V2 final. So both of these objects have to add up to 0. Their final momentum has to add up to 0. So one will be positive, one will be negative. So solving it for V2 final, we subtract mass 1 V1 final from each side. And we get negative M1 V1 final equals M2 V2 final. Now we simply must divide by M2 on both sides, and we will have a formula for V2 final. So our formula for V2 final for a simple explosion with two objects moving away from each other, V2 final equals negative M1 V1 final, or the negative momentum of the first object divided by the mass of the second object. I'm going to put a box around this because this is a formula you might want to write down and save for future use for explosion problems. And if we plug in our numbers now, mass 1 is 45 kilograms. So negative 45 kilograms times V1 final, which is negative 4.5 meters per second. And it's negative because the way I've drawn it, it's skaters moving backwards to the left, which is my negative direction. And we divide by mass 2, 61 kilograms. And V2 final will come out to be positive. So let's multiply 45 times 4.5 divided by 61. We get a final answer of positive 3.3 meters per second for skater 2. That's all there is to the explosion problems. And that is the end of this lesson on conservation of momentum.